Hi, today we are going to see about frequency reuse concept in design thinking based delivery. So empathy, main issue faced by cellular networks owner is traffic volume growth. In every year 60% to 120% annual growth in data volumes occurs. So in mobile network any upgrade made to a part of the network it is consumed by the growth. The large cellular companies like Verizon, AT&T, Docomo, Airtel are handling this with big annual capital budgets for network improvements. But they will be the first to tell you that even with those expenditures, they are only putting band-aids on the problem and are not able to override the demand curve. Early mobile radio system was to achieve a large coverage areas by using high power transmitter with an antenna mounted on a tall tower. In this case, it is impossible to reuse those same frequencies throughout the system. If we use the same frequency throughout the system, interference occurs. Any attempts to achieve frequency reuse would result in interference. Frequency reuse is a system level idea which calls for replacing a single high power transmitter with low power small transmitters with each providing coverage to only a small portion of service area. Each base station is allocated a portion of total number of channels available to entire system. Nearby base stations are assigned different groups of channels so that all the available channels are assigned to a relative small number of neighboring base stations. Nearby base stations are assigned different groups of channels so that interference between base stations is minimized. What is a cell? A cell is a basic geographical unit of a cellular network, which is the area around an antenna where a specific frequency range is used. When a subscriber moves to another cell, the antenna of the new cell takes over the signal transmission. The group of cells, that is a cluster, is a group of adjacent cells, usually 7 cells, in which no frequency reuse is done within a cluster. The frequency spectrum is divided into subbands and each subband is used within one cell of the cluster. In heavy traffic zones, cells are smaller, while in isolated zone, cells are larger. This is the block diagram which shows how frequency is reused within the cluster of cells. In this, each cellular base station is allocated a group of radio channels within a small geographic area called a cell. Neighboring cells are assigned different channel groups. By limiting the coverage area to within the boundary of the cell, the channel groups may be reused to cover different cells, which keep interference levels within tolerable limits. Frequency reuse or frequency planning is the another name. The design process of selecting and allocating channel groups for all the cellular base station within a system is called frequency reuse or frequency planning. The characterizing of frequency reuse is considering a cellular system which has a total of S duplex channels. Each cell is allocated a group of K channels where K is smaller than S. The S channels are divided among N cells. The total number of available radio channels is given by S equal to Kn. The N cells which use the complete set of channels is called a cluster. The cluster can be repeated M times within the system. The total number of channels C is used as a measure of capacity, where C is given by M into S or MKN. The capacity is directly proportional to the number of cell replication M. The cluster size N is typically equal to 4 or 7 or 12. Small n is desirable to maximize capacity. The frequency reuse factor is given by hexagonal geometry which has exactly 6 equidistant neighbors, and the line joining the centers of any cells and each of its neighbors are separated by multiple of 60 degrees. Only certain cluster size and cell layout are possible. The number of cells per cluster can only have values which satisfies n equal to I square plus ij plus j square. Co-channel neighbors of particular cell, example I equal to 3 and j equal to 6. The cluster size and cell layout is given in this block diagram. Here, cell reuse example is given in this slide for cluster size 19. To find the nearest co-channel neighbor of a particular cell, the first step is to move I cells along any chain of hexagons. Then turn 60 degrees counterclockwise and move j cells. The advantages of frequency reuse is it solves the problem of spectral congestion and user capacity. It offers very high capacity in a limited spectrum without major technical changes in the base station or mobile switching center. Reuse of radio channels in different cells is possible in frequency reuse or frequency planning. Enable a fixed number of channels to serve an arbitrarily large number of users by reusing the channel throughout the coverage region. This will avoid handoff, which is another advantage over the sectoring approach. Thus, a given channel is being used only in a particular zone in which the mobile is traveling. So the base station radiates its power in a localized manner. This will reduce interference. The microcell concept is very useful along highways or in busy urban areas. The channels are distributed in any time and space by all the zones and are also reused in the co-channel cells. The assessment questions are given in this slide. Okay, thank you.